thought process when I'm going through what to do. Is that too dark? You guys still see the light? This will brighten in a second. It just takes a minute to adjust. Okay. So, like what I'm asking myself on every question is area, pi over evolution, or cross section. And then once I get to that, I'm going, okay, x's or y's. And then I just kind of start plugging into my formula. So for this first one here, it says area, right? So I know right away. I'm doing area. Nope. Why is that? That's blue, right?
Right green one.
I keep pressing the green one?
No, you have to use the right green one. It really wants you to.
The blue doesn't work.
There it is.
Alright. Alright, so I want area. And then I'm going, okay, do I want to do the problem in terms of x or in terms of y? And you're looking at what the equations that you're given are in terms of. So these are in terms of x. Remember, solved for y means in terms of x. So I'm going to do this problem in terms of x, and I want to find the area. So I need to go x value, x value. So I'm going to put I'll put XL for x, the left-hand x value, XR for the right-hand x value. And then I want to do top minus bottom and times dx. How do I find these two, what I'm calling like x left and x right? Use your solver. So set those two equal to each other in solver. Go ahead and do that and see what you get. X equals -2, x equals 0, and x equals 3. Does everybody agree with that? We're on the same page there? So if I have 3 intersection points, how many integrals am I going to have? I'm going to have 2. So I'm going to be integrating from -2 to 0 of top minus bottom times dx plus 0 to 3 of top minus bottom times dx. Why is there not a pi out in front? I'm not revolving around anything. Why are these not squared? Not revolving around anything. It's not area of a square, rectangle, triangle, like that. That's just the straight up area between them. So you're just doing top minus bottom, no pi, no revolving, no square, anything. How do I know what's on top and the bottom? I don't necessarily, so I just guess. So I'm going to go x to the third minus 6x minus x squared, and if I'm wrong, the absolute value's got me covered. So that's going to just turn whatever I found positive. And then same thing here. I don't know what's on top or bottom. Doesn't really matter because if I'm wrong, it just comes out negative. And I'll type those in. So if you want to go ahead and type them in, take a second, make sure you're getting it right. You can do that. Oh, wait. Questions on the setup at all? Did I put the answers as just the setup? Okay, well that's fine. But I mean, we can do the we can check the answer and make sure we all get the same thing, though, you know. But if you just the setup at this point, it's totally fine with you. I know you guys know how to type into a calculator. Am I getting an answer? 16 over. Do other people agree? Was it negative? Okay, so that was the right order. Agree, 63 over 4. Then you just add those up. Whatever you mean. I know you can. 253 over 12. Look at that circle. You can't even tell where it started and stopped. It's perfectly closed. It's not a perfect circle, but it's perfectly closed. There's no starting and stopping point. Yeah. Anyway. Yeah. I just want to keep looking at it.
Appreciate that. What a beautiful circle.
Questions on that one? My guess is, so this is what I feel like, you can tell me if I'm wrong. When we were doing like, here's a formula, here's how you do this formula, here's a worksheet on exactly only this formula, everything was fine. But now that I start like mixing them up, that's when it gets a little bit tougher. Is that fair enough statement?
Yes.
Okay. Not mean to erase that. Is everybody okay? That might need that. So let's do the second one then. So the first thing I'm looking at is an area, revolutions, or cross sections. Those are the three things we did. Area, revolutions, or cross sections. Area. So just it says find the area, right? And then, do I want to do the problem in terms of x's or in terms of y's? I want to do it in terms of y's because these are solved for x in terms of y. And I can't like flip that around. Like I couldn't solve that equation for y to put it in terms of x. It wouldn't work. So if I'm doing it in terms of y's, this is where you got to keep these straight. When I do my integral, is this going to be the left and the right or the bottom and the top? Think about, we're doing it in y's. What do y values represent? Left and right or bottom and top? They represent bottom and top. So this is going to be like your bottom and your top. You might have more than one integral. They gave me -4 to 1, but how do we check if there's other intersection points? Put it in solver. So go ahead and put those in solver and see if there's an intersection point in between there. Remember, if it's like 3, if it's outside of here, I don't care. But I don't know if there's one in between there or not. So go ahead and put that in solver and check. Just let me know if I'm not doing it. So whenever it's left and right, if you have left and right borders, then you can subtract. So if you think about, like, if I have a left-hand border and a right-hand border, then within that, I'm going to have something on the top and something on the bottom. And if I'm doing the other way, I'm going to have a bottom border, which would be a y value, and a top border. Then you're going to have shapes in here, and you're doing right minus left on bottom, right there. It's like backwards. But every time it's bottom and top, you're doing right minus left. And every time it's left to right, you're doing top minus bottom.
Okay, I was probably just I knew that, but like I was just
Okay. Is there an intersection point in between there? Y equals -1? People agree? Okay. So then I got to go from -4 to -1, and I've got to go from -1 to 1. And then this is what I was talking about. If I have a bottom border and a top border, that puts me in like this, this kind of tunnel. And then I'm going to do right minus left within that tunnel. And I don't know which is which. I'm just going to guess. And throw the absolute value signs there. dy or dx? dy. So every single thing in this integral is a y value. The lower and the upper, these are y values. These are all y's. You got your dy. And then the same thing down here. And I wouldn't even worry about the answer. Again, I know you guys can type. It's the setup I want to make sure we're getting correct. So questions on that? What I did to set that one up? Why'd you put this here? Why is it this? I thought it was this. Yeah.
Is this y over 2 like the second subtracting you have to put parentheses around it? Or?
No. Because if there were like more than one term, you need to. I just did it every time you say it. Any other questions on that one? Okay. So let's slide down. So look at number 3. Is that area, revolutions, or cross sections? That's your first job. So revolved about the x-axis, right? And then we got this thing here, so it's revolutions. And if we're revolving around the x-axis, so this shape is going to go like this way. So everything I put in that equation has to, revolving around, is the x-axis horizontal or vertical? It's horizontal. So if I'm revolving around a horizontal line, I'm going to have a left-hand border. That was supposed to be a problem. I'm going to have a right-hand border, and then I'll be looking like top minus bottom. Should the whole problem be done in x values or y values? It should be done in x. I need a left-hand border and a right-hand border, and which values provide left and right, x or y? It's x. So I need to find, well, I can start off with my general form. Man, this is a struggle. Are you serious? Okay, we'll do it over here. You're going to have like the outside top minus bottom squared minus the inside top minus bottom squared. And then, am I doing my dx or dy? Dx. So that, I mean, just pointing this out over here, if you're going around a horizontal, everything's x. Left x value, right x value, dx, and every variable in there should be x. So I need to find the 2x values that go here. And I have a graph, you'll have a graph on these. So what are the 2x values that go there and there? Like what's the left and right hand values of the shape that we're looking for? 0 to 1, right? I wish they would zoom in on that a little bit. But. And I think it'd be helpful to label all these lines too. So which one is that? That's x squared. Which one is that? X equals 1. Vertical lines are x equals. And then y equals 0 is what? The axis, right? So if we're able to like zoom in on this shape, we've really got x equals 1 there, y equals x squared there, y equals 0, and we're flipping around y equals 0. So this kind of triangle-ish thing is going to come out around, go through the other side of the wall, and make like a three-dimensional ice cream cone looking. Yeah. Ruining the... What? Okay. Watch how this is going to go now. What am I missing? A pie. Why is there a pie there? No, you didn't notice. Why is there a pie there? Because I'm revolving, and when I revolve, what shape do I make? I make circles. I don't have it up there, do I? What? No, I think there should be, if you wrote this down today, you should probably check that if you wrote it down before too. I've got to put the pies there. So if you just copied that, make sure you put the pies. Okay, so which equation? So this x equals 1 is not revolving anywhere, right? That's just kind of like the wall. So the shape is going to revolve, like between these two x values, it's going to revolve. So the 0 and the 1 don't go anywhere. That's just like locked into place as your borders. And then this is kind of our thought process we do. Which equation, so these two are the ones that are going to be involved in the rotation. Which one is farther away from the axis of revolution? Y equals x squared. And how far is it from y equals x squared to the axis of revolution? What is that distance? Top minus bottom. So it's always top minus bottom. So it's x squared minus 0. And then, which equation is closer to the axis of revolution? Is y equals 0, isn't it? Like, isn't it right on the axis of revolution? So how far is it from y equals 0 to the axis of revolution? It's technically 0 minus 0. So it's really just 0. And remember, what that second part is doing is subtracting out like the hole on the inside, kind of the donut, the inner part of the donut. But if I'm right on the line I'm revolving, is there an inner part of the donut? No. So there's nothing to subtract in this case. And you don't have to write this. You can write this. Questions on the setup of that anywhere? Why did you choose this? Why is it top minus bottom? Why did you get?
So if we simplified it and like made it like without the zeros, is that
Totally fine. But if you screw up the simplification, I'm going to mark it wrong. So there's no real benefit. But if it's multiple choice, you got to be able to match it up and say, okay, well, like this would be the same thing, right? But if you just asked to write an equation, I would not simplify it because you have things to lose and nothing to gain. Yeah.
It's been a while, I can't remember. If y equals 1 instead of y equals 0, and you were still revolving around the x-axis, would it be 1 minus 0?
Okay, so in general, I see where you're going, and yes, but y equals 1 in this case would kind of cut through our shape, and we'd be a little bit... Now we're in Calc 3 all of a sudden. But I know what you're saying. If, let's say we're evolving... Let's just do this. Here. Can I erase this? Everybody work on this? Yeah.
I don't remember. She just wanted to ask you a question, but she felt like
I'm just going to keep going.
it wasn't about that, so
Okay.
it was about
I want you to do this problem again, but revolve around y equals -2. I think this is kind of where you're headed. What? This is a different shape. Well, then I'm still going to do it. Back off.
saying it is noticing that it's the same.
I noticed things about you too. I'll bring them all up.
Oh, I remember my question.
Okay.
On the test on Tuesday, are you going to have us just evaluate the integral or just set it up?
On the test on Tuesday, it'll probably be like half and half.
So read the questions.
Yeah. Reading.
To remember to read to see if we're figuring and setting it up or not.
This part stays the same, right? We still have our same borders. We're just coming down to a different. I don't know what that was supposed to be. That's downstairs. Like art, or I don't think that's bad. So if I'm going around y equals -2, you're still asking yourself kind of the same questions. This is y equals x squared. This is y equals 0. We are going to rotate around y equals -2, but we still have these walls that tell us, okay, this is x equals 0, this is x equals 1. The walls don't move. The walls are x values, and that kind of helps me remember everything in here needs to be an x value. So now which equation is farther away from the axis of rotation? Y equals x squared. And what is the distance between x squared and the axis of rotation? X squared minus -2. So it's the top minus the bottom. So the top minus the bottom there. And then which equation is closer is y equals 0, and how far apart are those two? Well, they're 2 apart, right? But if we're going with our formula, it'd be like 0 minus -2. All right. Question on that? Because we're gonna do one more with this. So then let's flip it. Let's say now we're going around. So we're sticking on the same question. We're gonna go around y equals 5. So now I'm putting the axis of revolution above your shape. So see if you can think through what that does. So now, which equation is farther away? Is the y equals 0, right? And how far is it from the axis of revolution? It's 5, I mean, they're 5 away from each other, right? But it's 5 minus 0 is technically what's happening. And then which equation is closer is y equals x squared. And how far apart are 5 and x squared? Which one's on top? So 5 minus x squared, right, Jasper? Does that make sense? Okay. How many of that? Okay. Questions there? So let's do when will we go the other way? Let's go to number 5. No, number 6 is tougher. Let's do number 6. Okay, so area, revolution, or cross section? Revolution. So I can start off. As soon as I see revolution, I can do this. And kind of set up this part, and I don't know that I'm not going to put that yet. And then think about, are we going to do this problem in terms of x's or in terms of y's? Like, is this going to be dy or dx? Are these going to be y values or x values? Y's or x? It's going to be y's. And the easiest way for me to think about it is if we're rotating it this way, like if you're rotating something around this way, it's kind of like this here. You have this tunnel where you have a bottom wall and a top wall, and you're rotating within that. And so those bottom and top walls are y values. Does that make any sense? You could also just memorize it. If I'm rotating around a vertical axis, you're going to use y's. That's kind of the other way you can get to it. So what are the two y values here? Like the bottom and top of my shape, 0 and 2. So then now I know this is an x or a y. This is the part where you say either x or y. That's a y, right? Everything I put in here has to be the same variable. If these were y values, that better be a y value, and everything I put in here better be y values also. So let's start labeling equations. Lines on here. That is x equals -1, right? That's what they're telling me to rotate around. What is that? That one's x equals 1, right? Vertical lines are x equals a number. This one is y equals 2. I don't really need that anymore. That was the only purpose of that is your top wall. And so that number goes there. This one I guess you could look at, that's y equals 0. Doesn't really matter. That's just your bottom wall. And so I'm done with that too. The hard part here is I got to label this equation. But if I look at the way it's written now, can I use it the way it's written now? I can't, because I can only put y values into my equation. So what do I have to do with this first before I can keep going? I have to solve it for x, right? So I'm going to square y squared would equal x minus 1, which would give me x equals y squared plus 1. And that is how you want to label it, because we have to label it in the variables that we're working with. Questions up to there? Then, what's the next question I think about? Before right and left even. Because there's two right and lefts, right? So I usually start with which one's farther away, and then do right minus left, and then closer, and do right minus left. Yeah, that's probably where you're headed. But so which equation's farther away from the axis of revolution? This y squared plus 1. First of all, I guess, what are our two equations? What's this equation? X equals 1, and this is the y squared plus 1. But we're rotating around, way over here. So the one that's farther away is the y squared plus 1. And what is the distance from y squared plus 1 to negative 1? Y squared plus 1 minus negative 1. So I mean, it could end up just being y squared plus 2, but you don't have to do that. And then which equation is closer to where we're wrote to the axis of revolution? Is x equals 1, and how far is 1 from our axis of revolution? You could say 1 minus negative 1, or you could just say, well, they're 2 apart from each other. Questions on there? I still don't get this. Where's this coming from? Is this helping? So let's do, okay, I guess I just did. Let's do a couple of cross-section ones, just to review. So cross-sections with x we've done, cross-sections with y is the only thing we haven't done yet. I don't know which one looks hardest here. Let's do 10. Nope, that's perpendicular to the y-axis. 9 and 10, you shouldn't even be on here. We haven't done 9 and 10 yet, I apologize. Let's do 7. So areas, revolutions, or cross-sections? Cross-sections. A cross-section is always going to be the integral of the area. Am I going to do this, is this going to be dx or dy? For cross-sections, you look at the variable that they're telling you it's perpendicular to. So like if it's perpendicular to the x-axis, you're going to be doing dx. If it's perpendicular to the y-axis, you're going to be doing dy. So this is going to be dx, which means what needs to be true about these two values here? They have to be x values. So they're going to be like my left and right boundaries. And what are those? -5 to 5. I'm going to try to sketch it just because I think that helps you see what's happening. The cross-section is perpendicular to the x-axis. So perpendicular to the x-axis is this way. Are semicircles. And if they don't tell you radius or diameter, you assume it's the diameter, and it's semicircles kind of popping out of the board like this, which, if I could do this well, it would make a three-dimensional shape. You can kind of see what's happening there. And my job is to integrate the area. Well, what's the area of a semicircle? So I would say 1/2 pi r squared. So I want to integrate 1/2 pi r squared. But I'm going to leave the variable part blank. Dx or dy here? Dx, because I'm perpendicular to the x-axis. And then, in place of the radius, every one of these things is a radius. So the distance from this equation, I'm sorry, I'm mixing up the diameter and radius here. These distances here, from the top, from this equation to this equation, are they diameters or radii? They're diameters. But I need to make them into a radius to put them in my equation, right? So what I have to do with these distances? Divide them by 2, and what is this distance? In general, what's the distance between here and here? It's 5 at that one spot, but what about there, 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 there? What's the general form for the distance from here to here? Top minus bottom. That's what I'm trying to get you to say. I don't know if I'm asking it well or whatever, but top minus bottom is this distance. So 5 counts, Jasper, like right there at that one spot. But if I use the formula, it applies like the whole range. So top minus bottom is the square root of 25 minus x squared. Minus 0, that's a diameter. I need to divide it by 2 to turn it into a radius. And then if you look at your answer key on these, a lot of times they'll have, and this will be true on the test too, you might see this. They might put like the pi over 8 out there. So this is how this would probably be simplified. So a couple things to talk through here. So that this divided by 2 was inside of the square. So when you square it, aren't you actually dividing by 4? And then, so there's like a 1/4 here that I'm like pulling out, and there's a 1/2 here. 1/2 times 1/4 is 1/8. Your pi goes on top. And then the square root and the squares cancel. So again, if it's free response and you stop here, it's correct. You do not have to keep going. I wouldn't want you to, because you might screw up. If it's multiple choice, you got to be able to take that next step and say, okay, I can see how they're getting to this. This is the same thing. Questions on this one? Anything else I can help? I hope that was helpful. So finish that. You know, the rest of that's your homework. I'll answer any questions on it tomorrow. We'll do the final formula over there. Monday practice tests.